Assalamualaikum and hello. In this video, I'm going to introduce to you another balancing, which is redox reaction. Redox reaction is a reaction that involves both reduction and oxidation. So in order for you to balance redox reaction, you have to know which compound is being oxidized and which compound is being reduced. First thing first, let's see what are differences between oxidation and reduction. For oxidation, the substance loses one or more electrons. The next point, you have to see the oxidation number increases. And last one, if the substance undergoes oxidation, it will act as reducing agent, or another word, reductant. For example, sodium is a reducing agent because it loses one electron here. You can see from 0, it becomes positive 1 because loses one electron. Next, we go for reduction. Reduction is for the substance that gains one or more electrons. So you can see the oxidation number decreases, and they usually act as oxidizing agent, another term, oxidant. For example, you have hydrogen accepts one electron to becomes H minus. So you can see the oxidation number for hydrogen originally is 0, but when it accepts one electron, it becomes negative 1. So the differences between reducing agent and oxidizing agent, you have to understand that when the substance acts as reducing agent, it will lose electrons and is being oxidized. So this substance A undergoes oxidation, and for B is vice versa. Now I'm going to introduce to you how to determine oxidation number. This oxidation number is very important so that you can balance your redox equation later on. So there are few rules. We are going to go one by one. The first rule is elementary form. For example, atom or diatomic molecule, their oxidation number is 0. You can see from example 4, sodium, magnesium, and then you got a few molecule here, bromine molecule, oxygen molecule, and chlorine molecule. All of these got oxidation number which is 0. So you just write it down as 0, the value. Next, we go to the second rule, group 1 and group 2 elements. For group 1 and group 2 metals, the oxidation number is equals to the charge. For example, group 1, it loses 1 electron, so the charge will be positive 1. Oxidation number for group 2 elements, they loses 2 electrons, so the charge will be positive 2. So when you have examples like these ions, you can say that for sodium ion and potassium ion, the oxidation number will be positive 1. And for magnesium 2+ and Ca2+, it will be positive 2. Now let's go to the next rule for monoatomic ions. Monoatomic ions, the oxidation number for monoatomic ion is equal to the charge of ion. For example, I have a few here. So you can see that the oxidation number for O2- is negative 2. For Al3+ is positive 3. Please make sure when you write the oxidation number, the positive sign should be at the front of the number. But in the notation, positive sign should be behind the number. So I hope you're still clear with this. Next, from Mg2+ is +2, and last one is negative 2 for S2-. So this is very simple for monoatomic ion. Let's go to the next one. We have halogens. Fluorine and other halogens always have oxidation number -1 in its compound, but they only have positive number when combined with oxygen. For example, I have NaF, so I want to determine the oxidation number for fluorine in NaF. I can write it down as -1. Same goes for Cl in HCl. The oxidation number for Cl is -1. But when I have Cl2O7, this is where your halogen chlorine combines with oxygen. So it will not be -1 anymore. For this case, it will be +7. Next one, we have rule number 5, which is hydrogen. will be always positive 1 for its oxidation number, except for metal hydride. So how I want to understand more about this, for example, I have oxidation number for hydrogen in HCl, so it will be positive 1. However, when you have metal that combines with hydrogen, for example, I have NaH, sodium is metal, so the oxidation number will be changed into negative 1 for hydrogen. Same goes for hydrogen in MgH2. Magnesium is a metal, so the oxidation number for H is negative 1. Let's go to the next rule for oxygen. Oxygen has oxidation number of negative 2 always in most of its compound. For example, I have oxidation number for O in MgO, so it will be negative 2. Oxidation number for oxygen in H2O, it also is negative 2. So please remember, hydrogen always positive 1, oxygen always negative 2, halogen always negative 1. But there are certain exceptional cases that you have to alert. So the same goes for oxygen when there are two exceptional cases. For example, in peroxide, this is the next rule where its oxidation number is negative 1. For example, I want to determine oxidation number of oxygen in peroxide, H2O2, it will be negative 1. And the next case, when oxygen combined with fluorine, it will possess a positive oxidation number instead of negative. For example, I have here oxidation number of oxygen in OF2, it will be positive 2. So that's it for peroxide, which related to the oxygen. Now we are continuing with the next rule, neutral molecule. In neutral molecule, the sum of all oxidation number for all atoms made up the molecule is equal to 0. So you have a few examples here. You got oxidation number of H2O, all of these made up as 0. Same goes for HCl, you got positive 1 for hydrogen, negative 1 for chlorine. So when you add up, it will be 0. And same with KMNO4, you will have 0. So it's very important for you to understand this rule so that you can determine a specific element in the compound given. Last but not least, we have polyatomic ion, the last rule where the total oxidation number for all atoms made up the polyatomic ion must be equal to the net charge of the ion. For example, I have MnO4-, where the oxidation number will be same as this charge, negative 1. For example, I have Cr2O72-, so the oxidation number will be negative 2. And same goes for NO3-, oxidation number will be negative 1. So if I ask you to calculate the oxidation number for the summation of them, for example, I have NO3-, the sum of oxidation number should be same to this charge, which is negative 1. So you can see from here, positive 5 for nitrogen, negative 2 for oxygen, times with 3 of them, you will get negative 1. So I'm going to explain to you by using one example, example 14, where I ask you to assign oxidation number for chromium in Cr2O72-. So this is a polyatomic ion. So the solution for this part, you know that the charge for polyatomic ion is equal to the summation of oxidation number. So you can write it down, Cr2O72- equals to negative 2 because of the charge is negative 2. Next, I'm going to separate the atoms in Cr2O72-. So I have 2 chromium atoms and 7 oxygen atoms. So I will have the oxidation number for oxygen, which is always negative 2. I put into the equation, so I will have this value. I'm going to find out the chromium, so you will have the leftover positive 12 for 2 chromium atoms, but only for 1 chromium atom, so you rearrange, you will have 1 chromium atom is positive 6. So the oxidation number for chromium in Cr2O72- is positive 6. So this example is one of the most important thing when you want to start balancing redox reaction. So I hope all of you understand about the importance of oxidation number in this video. We will try to apply them in the next video. I'll see you in the next one. Bye!